paper of the day is Apache Flink, Stream and Batch Processing. This paper presented Apache Flink, a platform that implements a universal data flow engine designed to perform both stream and batch analytics. Flink's data flow engine treats operator state and logical intermediate results as first-class citizens and is used by both the batch and a data streaming APIs with different parameters. The streaming API that is built on top of Flink's streaming data flow engine provides the means to keep recoverable state and to partition, transform, and aggregate data stream windows. While batch computations are, in theory, a special case of a streaming computations, Flink treats them especially by optimizing their execution using a query optimizer and by implementing blocking operators that gracefully spill to disk in the absence of memory. In terms of system architecture, there are four main layers: deployment, core, APIs, and libraries. Flink's runtime and APIs. The core of Flink is the distributed data flow engine which executes data flow programs. A Flink runtime program is a DAG of stateful operators connected with data streams. There are two core APIs in Flink: a dataset API for processing finite datasets, often referred to as batch processing, and the data stream API for processing potentially unbounded data streams, often referred to as stream processing. Flink's core runtime engine can be seen as a streaming data flow engine, and both the dataset and data stream APIs create runtime program executable by the engine. As such, it serves as the common fabric to abstract both bounded and unbounded processing. On top of the core APIs, Flink bundles domain-specific libraries and APIs that generate dataset and data stream API programs. Currently, Flink ML for machine learning, Jelly for graph processing, and Table for SQL-like operations. The paper makes three key contributions. It makes the case for a unified architecture of stream and batch data processing, including specific optimizations that are only relevant for static datasets. It shows how streaming, batch, iterative, and interactive analytics can be represented as fault-tolerant streaming data flows. It discusses how they built a full-fledged stream analytics system with a flexible windowing mechanism, as well as a full-fledged batch processor on top of these data flows, by showing how streaming, batch, iterative, and interactive analytics can be represented as streaming workflows. Now let's talk PS score for this paper. Overall, this paper is a decent read, so it gets 9 out of 10 on readability. With 11 pages long, it scores 9 out of 10 on length. It's an analysis of an existing system with pretty good description, so that makes it 9 out of 10. Its industry value and learning meter is pretty high, so it gets 9 out of 10 on each. Overall PS score for this paper is 9 out of 10.